Hello everyone. Today I'm going to show you BFS for graph. In my last video I show BFS for tree. Today I'm going to show BFS for graph actually. So there is only few difference between graph and tree. We all know that in graph we have the concept of neighboring nodes. So there will be a set of nodes that's neighbor to a particular node. That's the concept of graph. If we are going over a tree, we already know that how it will structure. So basically we will have a value and a list of children. So basically the two are different concepts. So uh, I will start I will start a program for BFS, but first search for a graph. So we can create a class right now. I will give a name like BFS graph. Probably I will create another class and I will give the name class graph. Okay, and what we will have for graph, that's another one. I will create it as a generic one so I can use integer whatever. Okay, then I will create a value since it's same for the tree, and we will have a set of graph with generic indication. So we will call it as a neighbors. Then I will do everything same like what we did for tree. So basically I need to insert the constructor with only one value. Probably it should be the value itself, and inside that I will just mention neighbor is empty right now. So it's a new hash set. So right now our constructor is ready, and we will have another method. What we will do here is we will connect between graph nodes. So basically, oh sorry, graph G, we can call it as a graph or something. Probably not. I guess graph would be fine. Then inside that, so I have graph. If this equal to current graph, then what I will do, throw new illegal argument exception. So basically what I'm doing here, if I am passing the same graph node to connect, it should fail. I mean it should throw an exception, illegal argument exception. Can connect a graph node to itself. So that's what. So right now our no, there is one more thing that I need. These two neighbors dot add that particular graphs. Okay, what else I need? So for that one, yeah, for each graph, so we are passing only one graph, right? One graph now. So one graph neighbors, we will add these two because it's a mutual connection, right? So basically we need to connect the parent one node into the neighbors, and then only one neighbor here mentioning to connect. So and we need to connect the neighbor to the node. So basically it's a mutual connection. So I did that. Then what else we need to do? So we are going to, okay, right now we are going to the same method here. Here I will define a public whatever I did for tree. So basically if I am going for tree, here I create a method called optional search. Probably I will copy paste that. Just change the method signature. Okay, optional I already import. Then instead of tree I will mention graph. Probably row will be a good idea. I don't know. Probably we can keep like that itself. Then inside that what I will do, I need to add, I need to create so many stuff I need to do here. So I have a root one. No, this is a search method. So basically inside that search method, and since we are doing the birth first search, I need a queue, and that queue accept graph with the key, and name should be queue. Ready queue. Then queue to add current graph. Since it is a root I mentioned, I will add it as a graph. Okay. Then what else I need? I need to mention the current. Okay. Okay. Graph T current node. Okay. Current node I will mention here, and I will have another one with set. Here I will mention already visited, and it should be an hash set. Okay, right now we are going to parse through all the nodes. So we need a while, and we have already queue. Queue is empty. If queue is not empty, then our current node current node is equal to queue dot remove. Okay, so I got the first element. Then from here we need to compare whether the current node is equal to the value that we pass. So current node dot current node get value. Okay, need to do some other thing also here. Okay, right, it's almost done. Get value equals value. Then what I will return optional of current node. That's done. Then yeah, there is some issues here. Okay, that's regarding the definition. Okay, I know it's okay. Then if it is else, we need to do some other stuff also. Already visited, we have said, so I will add to that. We will add the current node. Then Q will add all here. Current node get neighbors. Then Q remove all. We need to remove the current. Already visit all nodes we need to remove. If there is anything on that queue that already visited, I need to remove that. So I did that too. So right now I guess we are okay right now. To this one we need option empty. So we are ready to go right now. Probably for checking this one. Okay, I will have a first value. I mean first graph value. So what I will do, graph, and it should be string, and I will g1 or something. Then new graph, we should have a value. So probably first. Okay. Then what I will do, I will have a second one. I will point it as G2 second, and I will have another graph node with G3. I will mention 3. So what I will do is I need to connect G1 to G2. I need to connect G2 to G3. So here G1 connect to G2, G2 connect to G3. Probably I will connect G3 connect to G1. Okay. Right now everything is fine. So mm, next thing that I need is system dot out dot println statement, and I will call this search method. What I will pass is June 3. Okay, we can just run this to make sure whether it's, yeah, it's just running. Okay, there is a lag in building. Sometimes IntelliJ will, yeah, right now it's okay. Waiting. Yeah, yeah, come on. Okay, nothing. I forgot to mention something like that. Is present. Okay, save this one, running again to make sure it's okay. It's present. 3p. False. It's not present. So it's done. That's it.